Imagine a world where every device you rely on, your phone, your car, your home, suddenly stops working, where the fabric of modern life unravels in an instant. Now picture the tiny, almost invisible hero behind all this chaos. A microchip so small that it fits on the tip of a pencil, yet so powerful it can perform billions of calculations every second. This is not science fiction. It's the astonishing reality of the microchip, one of the most revolutionary inventions in human history. These miniature marvels are the unseen architects of our digital age, quietly orchestrating the complex symphony of technology that connects, empowers, and transforms us every single day. We'll journey back to their origins, discovering how the invention of the integrated circuit in the 1950s ignited a technological revolution, and how today's microchips have evolved into complex, multi-layered structures with billions of transistors working in perfect harmony. You'll learn how these transistors act as tiny switches, turning on and off at incredible speeds to process data, and how innovations like Moore's Law have driven exponential growth in processing power, shaping industries, economies, and everyday life. We'll delve into the intricate design and manufacturing processes, how engineers manipulate atoms and electrons with astonishing precision, and explore groundbreaking advancements like quantum computing and neuromorphic chips that promise to redefine our future. But how did these tiny silicon giants come to rule our world? What secrets do they hold? And how have they evolved from simple switches to the brainpower behind artificial intelligence, space exploration, and medical miracles? Today, we embark on an extraordinary voyage into the microscopic universe of microchips, delving into their history, science, and future, unlocking the mysteries of the building blocks that not only run our devices, but also shape the course of human civilization. Imagine holding a small piece of silicon no larger than a fingernail that contains billions of microscopic transistors, each acting as a tiny electronic switch that can turn on and off at blazing speeds. These are the building blocks of modern technology. And today, they power everything from your smartphone, laptop, and smartwatch to the engines of autonomous cars, medical devices, and even the systems controlling global financial markets. But how do these minuscule marvels actually work? What makes them so powerful and efficient? To understand this, we need to travel back in time to the 1950s, when the first integrated circuits were invented, sparking a technological revolution that laid the foundation for the digital age. We'll explore how scientists and engineers used silicon, a semiconductor material, to develop transistors that could be mass-produced, leading to exponential growth in processing power, a trend famously predicted by Moore's Law. As we peel back the layers of microchip design, we'll discover the intricate process of photolithography, doping, and layering that turns a simple silicon wafer into a complex, high-performance processor capable of executing billions of instructions per second. You'll learn about the sheer ingenuity behind miniaturization, shrinking transistors down to atomic sizes, while managing heat, power consumption, and reliability. We'll also glimpse into the future, discussing revolutionary innovations like quantum microchips and neuromorphic computing that mimic the human brain, promising to unlock problems we once thought impossible. But beyond the technical marvels, it's important to recognize how microchips have catalyzed societal shifts, empowering global connectivity, enabling breakthroughs in medicine, education, and entertainment, and creating new industries and opportunities. As we conclude, you'll see that microchips are not just components inside devices. They are the unseen architects of our digital universe, shaping the way we communicate, work, learn, and dream. And with rapid advancements on the horizon, the tiny world of microchips will continue to push the boundaries of what's possible, driving humanity toward a future filled with unimaginable innovation, making it clear that these microscopic powerhouses are truly the heart of the modern age, hidden yet everywhere, tiny but mighty, and essential for the world of tomorrow.